Welcome to today's webinar. Today's webinar is a follow-up to the Chapter 9 Detail and 3D Modeling course guide. We were talking at that time about the detail modeling and covered the intersection design using the vertical geometry tools and terrain building tools. Today I wanted to talk about some of the other details that we didn't really get into. And of those, kind of have them listed here. I want to go into what you do at median crown crossovers, particularly in relation to where traffic separators are opposing one another, or maybe not even opposing one another, but just happen to shift over to one side of the center line or the other. And then in the past, we've had a hard time modeling out traffic separator noses. So we actually have a pretty workable solution with a 3D civil cell that essentially is just a linear template that pivots, spins around itself, and completes the end of a traffic separator based on two traffic separator lines that have projected profiles to them. And then I also want to go into some of the other civil cells that we've built for this particular data set, and that is a urban driveway, a rural driveway. We've also worked in the actual exercises, turning island and modeling out the island at the intersection the intersection of 98 and State Road 61 in our project data set. And I'll show you how that can be built by hand, and then also show you how you could create a civil cell from what we just built. And then we'll talk about some of the other things like sidewalk ramps and some of the work that we're doing with sidewalk ramps. And we also have a retention pond template and civil cell out there, and I can refer you to some of that design. The restricted left turn islands right now is we know that's something that we need to put in as far as 3D civil cells, or even 2D civil cells for that matter, but I can discuss that a little bit. And then any other questions about like roundabouts or curb transitions, we can discuss some of those time permitting. So let me just go ahead and get into the design session here. I'm going to go back to this project data set. We're all familiar with it at this point. And at this point, we have intersection terrains modeled out, and we push some linear templates around the outsides. And now we need to start detailing a little bit more. For example, this traffic separator nose, I'll show you how that is, easy it is to do. Before I get into that, I want to show you what happens when you just, in this case, we have our normal template here that's a 4-lane divided, and it's projecting this left turn lane slope up. But then as soon as it gets on the other side of the traffic separator, it switches off and it becomes the 4-lane divided with a crowned median. And the reason for that is because that's the way our template is built. If you look at our template, I'll turn off these point names. The normal situation on our template is that we would have a crossover slope here, and it would crown, or it would be flat or whatever. And then whenever a traffic separator pops in there, if it sees a traffic separator, and that's a priority thing, it will draw in the traffic separator, and then the median turns out. And what happens is this pavement will try to follow wherever that traffic separator line is at the slope of this pavement here. And the reason that is, in case it was a super elevation, it would follow that same slope. But what ends up happening is the elevation of the lane obviously goes up above where a normal crown would be. And what you'll get in your model is a situation like this. Rotate around. You'll see that these are not going to match. So you see how this pavement has now adjusted itself up, and then this is using the curb slope, and then this is where the normal situation is. So in order to accommodate for this, what we have to do is somehow roll this pavement over to where it becomes a normal crown, like a normal crown situation. And typically the way that's handled, I think, in the field is that they'll sort of roll this thing over till it gets to the crown here, and it basically will slide this 2% lane all the way down to the middle over some distance. So all we have to do is, we provided for that in our template using these breakpoints here. And what this will do, if you just do a test on this, test the horizontal point control, you'll see that if you just add a point control line or a corridor reference, it will essentially allow this to roll over however it needs to on either side. And so that's all we're doing. If you look at the actual point properties, you'll see that it actually has a feature constraint horizontal for 20 feet across the median at a pavement slope break is the name of it. And so all I really have to do is add these back in as corridor references, and that's basically drawn from one end to the other. You'll also notice that I deleted out that circular nose because the civil cell will actually place that. Well, it's placed with the 2D traffic separator with turning lane civil cell, but we can also place it in here with a 3D. So once you've placed it with the 2D traffic separator and turn lane civil cell from back in Chapter 3, when we get into Chapter 9, we're going to go ahead and delete that, and I just did that ahead of time. So I'm just going to do a Control-Z because I just removed those references, and you see now essentially all I basically did is add these references back into the corridor, and I was just saving time since I had subtracted them from the corridor. I just basically added them back in. But now what you can see is this now transitions better, and that's important for how this crosses here so that you get a nice smooth roll over there. Now the next thing we need to do is sort of model out the nose. And what we do for that is we just go in here to the place civil cells, and within the civil cell library in the intersections DGN Lib, there is a traffic separator nose, and that's basically what this is. Probably should say 3D traffic separator nose because we're trying to differentiate what is a 3D civil cell and what a 2D civil cell is. So when you choose OK, it's going to ask you for the traffic separator element. And even though it doesn't say the right traffic separator the left traffic separator element, the way it was built was this should be the first reference, and then it wants to know the second reference, and that would be this one. And then it usually comes in at the orientation is wrong, so what you've got to do is just flip this, and then you flip this one as well, and then it will pop it in there, and it looks, from the plan view, it looks correct. And then you reset to change any alternates and accept the civil cell. And if it all comes in right, it will draw it in this 3D view as well once it's done processing here. Okay, just took a little while, that's all. And this is what you'll end up with, is this traffic separator. If for some reason this traffic separator doesn't come in, it comes in maybe twisted or spiraled, it's usually because there's a bad profile on one of these traffic separator lines. And that sort of kind of brings back the whole point of having to have profiles on these lines before this traffic separator cell will actually place in here. And the way we do that is just like we did back when we were doing the intersection, we actually grabbed from the vertical geometry this tool profile by 3D element, and I want to turn on these 3D line strings again. So all of the template points have line strings in the 3D view as well. And so in order to get a profile on a 2D element, just as a review, we use this tool here, profile by 3D element, and the two prompts are locate the plan element to profile, and you select that line, And then once you select that line, it asks you for the 3D element that you want to apply the profile onto that element, which would be the 3D line string. And when you've done that, you can go to the profile view for these elements and click in the view, and then you'll see the profile associated with it from the actual 3D model. Because remember, these are just 2D lines until we add the profiles from the model to them. Once they have profiles to them, then we can use, if you look at the profile for this 3D civil cell now, if we go to this, what it's really doing is it's plotting the 2 points that intersect the end of this line, and then it's striking a profile between there, and it's essentially using that to place a linear template around this this element. If I turn on my if I turn on the corridor boundaries, you would actually see a corridor boundary, sort of a well, there it is right there. Just the same. It just happens to be the same color as the traffic separator, but that's the actual linear template. And if you were to look at this template, what you'd see is it's really just a traffic separator that spins on itself half the distance, you know, across the median, and basically wraps a little top around the top of that traffic separator and builds it in there like that. So those usually work pretty good, and that's how you can add in that the details of that traffic separator nose. So that covers the median crown crossover and the traffic separator nose. The next thing I want to cover is the driveways.
Right, and it should automatically pick up that it's a 4-foot wide traffic separator and know to draw that nose in there.
So in this case, we've got
very forward for these guys to build fucking
possibly put in an urban driveway in this situation. And the way the 3D civil cells work in this case is, if you look in the, again, there's an intersections DGN lib, there's a driveways DGN lib. If you open this one up, there should be 4 different ones in there. There's a urban driveway that you can lay out just 2D. There's a rural driveway that you can lay out in 2D. And then you can modify these radiuses. In this case, you could modify the width of the urban driveway. You can modify the slope transitions here. Instead of being a 7-3 split, you could have a 6-4 split depending upon the width and according to the standards. You can change the sidewalk back distance. The one thing we don't have on here is the back pad, and you could do that easily with just making a little terrain out of it and having it tie into the existing topo, however you wanted. But this mainly controls the slope and a center line. I want to talk about some of these the other two here, and that is the 3D rural turnout and the 3D urban driveway. What we've done is we've gone ahead and made these 3D so that if you have a profile on these 2 lines, it will create all of the reference lines, similar to what you see in the Bentley videos. And then the 3D, the 3D urban driveway is that too. If you have a back of sidewalk profile and a profile on your edge of pavement, then this left line is basically all you need to identify, and it will project the slopes according to the standards for each of these driveway elements, which is what I'm going to attempt to place at this point. So I have this reference edge of pavement. It has a profile. I have a back of what I'm going to say my back of sidewalk line is for now right here, and it has a profile. And so then I just follow the prompts, and it asks me for the back of sidewalk, which is this one, and then the edge of pavement, which is this one, and then basically this says the construction line blue dash, but it's really the left side of your driveway. And once you've selected that, it'll attempt to place it in there. Of course, mine's going to place it perfect, but yours, you know, you'll have trouble with yours. No, just kidding. If you had to flip these, if it was on the other side, you might have to flip this line or flip this line or even possibly flip this line in order to get this orientation right. But if you're patient with it and just flip it and wait, flip it and wait, flip it and wait, you'll get it in there correctly as far as the 2D layout goes. And then once you have the alternates set the way you want it, it looks correctly in the plan view, then you just reset and accept. And this happens to be placed right here. So this is where that backup profile was, and if I get back into a top view, you'll see where this is being located. It's the same place in the plan. And now I have this urban driveway in there. But the first thing you notice is that this is the real back of sidewalk, and why did you place it all the way out there? There is a little bit of trouble with trying to use the full sidewalk element at this point, even if it has a profile on it. So all you really need to do is go in and identify a line within the limits of where your driveway is going to be, and it will try to place in a default 15-foot wide driveway. And then you can use the civil cell elements to actually change, like if you want to change this width here, or you could just change this this element here that's 7.6. If I want to set this at 5 feet from the back of that sidewalk instead, and just modify it there, and it actually modifies the whole civil cell and the terrain and everything. But notice it hasn't replaced the original sidewalk. And as a matter of fact, if I cut a section through here, you'd see both. But the other thing you can do is, if you want to identify the name of this this terrain here, it's called DTM Urban Driveway. What you can do is clip this terrain using the corridor clipping tools, and you can add a clipping reference to our State Road 61 corridor. I'm going to zoom out so you can kind of follow what I'm doing. I'm going to clip this corridor, and I'm going to use this urban driveway as a clipping reference, and then I'm going to reset. And it'll take a few minutes to process, well, not a few minutes, but a few seconds to go ahead and what it'll do is it'll clip out this existing thing, and now you see we actually have this 3D driveway. If I turn off the terrain element and rotate it, I've now got, and I've got to also clip out, I have to clip out the curb. See, I've got the normal type F. I need to clip out the curb with this new curb, so I'm going to do the same thing. I want to add a clipping reference here, select this corridor, and then select this linear template that's going across the front there, and reset. And that'll clip that curb out, and then you get a nice model driveway in there. This civil cell works only in a perpendicular situation. So if you had a skewed urban driveway, the civil cell wouldn't work. You'd have to go in and build that on your own. So now you see the actual transition here, the curb going down, and this is the actual driveway, concrete placed in there as well. It's just shows in white, but there, and you can see from a top view how that 3D driveway gets placed in there. Okay. The next one I want to show is the 2D driveway, and in order to do that, I'm going to come up here, and there's actually, if I turn on the topo in this view here, you'll see there's a driveway. Not that it really matters to y'all, but there actually is a driveway here called Alaskan Way. And what we need to do is create the urban turnout here. So this one has been somewhat cooperative, but you know, the whole workflow of being able to project, do a parallel offset for the side roads, and then put in your curb radius return on each of these. I mean, I could build this in about 10 minutes, but you can also use the civil cell to do the same thing. And I'll come up to, I don't see that line, so let me just make this, find out where this profile is for this view. It's too big. No, it's too small. Let me get it down here where I can control it. I'm going to display in here. And this shows the direction of the profile. That's one way to find out what the direction of the line is. And you can see I've designed this profile in here. So I just need to make this as the active profile. I guess it's just not a, there it is right there. So this is the location of it. And all I'm going to do is use the civil cell here, place civil cell, and find the 3D urban driveway, which was there, but I'm going to go pick it from the driveways again. I'm sorry, urban, rural turnout is what I need. 3D rural turnout. And it'll ask me for the reference line edge of pavement. So this has to have a profile. These are my milling lines, existing milling lines. So this is my proposed edge of pavement, my proposed shoulder. And so I'm going to select this, and if I hover over it, it usually tells me what it is anyway. So click there. And then it wants to know where the center line is. And then it will attempt to lay it in there according to the way we created the civil cell. And in this case, it looks like it's in the right orientation. I can visually see it. So I'll reset. And then if you want to clip the corridor, this one actually will clip it rather than have to do the clipping in the, afterwards. However, what we're finding is that clip corridors tend to take a lot longer to process, so you can save your clippings for the end. Basically, if you can get it all laid in there right first. And this also, if you've got side ditches and things like that, you can see how they would actually go, what the profile of it is underneath the driveway in case you needed to raise the driveway profile. So I'm going to reset and then accept this. And you'll see that the entire driveway gets placed out there with the shoulders, the terrain, the actual cutter fill slope on each side, and it's basically placed it in there. Now this one I think has a little issue with maybe the profile on that side, but all you need to do is go in and modify the this particular line's profile. In fact, I can do that if I just select this line and go to this profile view here. You'll see that it's got this really strange looking profile here. So what I can do is redesign this. I'll just do let me do it this way here. Just to make it show a little better, I'm going to redesign this. Obviously you wouldn't do it like this, but put a curve length in here of 50 feet. And then just kind of go back onto this line, reset. I'm going to set this as the active profile for now. And then if you rotate around, still got a little hump in there that, and I'm not sure what that is, but something that would need to be looked at. You could always just delete this profile. I think it's actually in the terrain. That's the issue. The lines are actually so that's something I need to work on. But that's the attempt at doing that 3D civil cell. And in this case, what I would do is delete the terrain and then rebuild it. But let's talk about the turning island next. So if I go back to a top view here, and let's look down here. Okay, this is our turning island that we placed in Chapter 3, where we actually put in all the offsets. And if you remember correctly, there was also a miscellaneous shape that we created out there. And that miscellaneous shape, we used it to figure what the area of this was. That was part of the exercises. But in this case, what we need to do is now, what we really want to do is, since we've warped our intersection terrain here, and while we're doing that, let me talk about this terrain. So if we go to the F11, this intersection terrain, this is the one we created in our last session, the last design and modeling. If you look at these in the model, in this file, there are terrain models, and here's our intersection model right here. And Right now, I'm just looking at the triangles of it. But let's say I wanted to see how this thing drained. Okay, from a top view, that's really easy. All you'd have to do is go to the properties. And because it's a terrain, I can turn off triangles and turn on contours, or I can leave the triangles on and just turn on the contours. And if I wanted to change the interval of the contours, I could go into the settings for it, which is on the element templates. And if you go into this particular file under terrain models, proposed, calculated features, if you look at the contour settings, what this is currently doing, it's giving me majors every 5 feet and minors every foot. But if I wanted to get more detail, I could change this to a major interval of 1 feet and a minor interval of 0.25 feet. And then basically go into the terrain model again. Hopefully this will work right. And now you can see what the contours look like on our warped intersection that quickly. And you could also go in there and look at the high spots and low spots. If you go to the properties here, you can turn on flow arrows. You could turn on the low points. And each of these will get displayed. Some of them get displayed, well, if you had them in this view, but a lot of it, most of it gets displayed over here in this 3D view. And that's a way that you can analyze this intersection. So let's say that you didn't like the way this was sloping. You had to put in another brake line or something. It'd just be a matter of going in and basically setting a line, giving it a profile, and adding it as a terrain feature. And basically that's how you can grade out your intersection after you've created it from boundaries. You can go in and if you wanted to, it looks like it's breaking across here. It's coming to a low point over here, and then this is coming to a low point over here, or possibly this is the high point and it's going around that corner probably. Yeah, that would be that situation. Looks like it's breaking here and coming to a low point somewhere around in here. So if you needed to regrade this a little bit, you could go into the profiles of these radius lines and actually rebuild it. So let me go ahead and add that traffic separator nose on here again, and then I'll talk about, since that's easy to add, I'll just go here to the intersections, traffic separator nose. I'll add it again. And if the first reference is always going to be the left side of the traffic separator and then the right side, and it usually pops in the wrong direction. In this case, let me just reset. Yeah, I couldn't really tell since this old one is still here. Let me delete that line. And then I'll place this one again. Select this line, then this line. And then usually I have to flip it. And let's see, let's flip it again. I got to be careful with my clicks here. All right, there it goes. And I reset and then accept it. And it takes a second to build that traffic separator nose, but eventually it'll place it out there. So that one, and then if you rotate, you can make sure that the profile looks right. It should hit the pavement there, and it should hit this one over here so that these lines connect. Everything looks good. So now we're going to add this traffic separator island. And in order to do that, I don't really have a civil cell at this point, but I'll show you how you could build one, or you can actually just create. Before I do that, I just want to make sure that I have a type E curve to place on the inside of this. So I'm going to go to my quarter modeling tools, and I'm going to go to the components, and I have a type F. I have a right type E, and nope, that's a type F. I'm not even reading it right. So let's see, what do I have for linear templates? I don't have anything on the inside. So this is where I would go to the template library, and I would go to our DGN library right here. No, right here. Find the f.itl file. And we have out there in the components folders, look at the wrong directory, components, curb and gutter, there's a type E inside. So this is the one we want to put in our components folder so that we can use that for our linear template. And now I have in here a type E inside. This looks like it's sloped at a small slope, so if you wanted to slope it up, you could set it 0.02, apply, and now it's raised it. Everything looks good, so I'm going to close and save this. Now, in order to run a linear template, it just has to have a line and a profile. So if I first go over to the horizontal geometry tools, I'm going to create a complex by element, and I'm going to do it from these. This is automatic, so if I just go ahead and it should, looks like my gap is too small, so let's set this gap a little tighter to 0.1 and then select and accept this line, this line. The reason I need to put these all together is because then I can make a smooth profile of them. And then accept it. And now I should have a complex element of these. Yeah, that one failed. So let me do it a different way. On miscellaneous 0, I actually have a shape that was created from the flood tool. I can use that shape also. It doesn't have to be a civil element, believe it or not. And then I can turn off this level in this view for pavement asphalt, and I'll set active miscellaneous 0 so I can turn this, and now I have this shape that's out here. And this is what we use to figure out what the area of that was. So, you know, there's a minimum area, and that's a good way to check it, is once you've placed this civil cell, 2D civil cell, you can just go to the area and find out what that area is. But now what I'm going to do is actually use this, get this profile from the first thing it's going to draw. Let me just close this. This profile draws what the existing ground would be for that particular island. What we really want is to see where it lands on this. So all you've got to do is go to quick profile from surface on this, and we're going to locate this line. I'm pretty sure this will work with this. And then you just locate the terrain, US 90, or I'm sorry, the DTM intersection 98. And then if you reset, it should give you what that profile looks like as it traces across the top of that. Once you have that profile, you can make it a little smoother if you want to, or you can just set it as the active profile. And what you'll get is a 3D line string that gets drawn out here. Possibly. Sometimes it doesn't get drawn on the right level, and I'm not sure what level. I think it may go on level default actually. I'll turn this back on. Yeah, I could be wrong. I'm not sure. I know there it does actually create a 3D line string, but it doesn't matter. As long as this line has a active profile, and this may be where I need to make it a chain. Because I'm not sure I can run a linear template around that element, but let's see. So if I locate this element, tell it to use a curb type E, and I may have to pick it from the pick list here. And then I'm going to Alt Start, and it will go all the way around this thing to the end. So I'm going to Alt to end it. And then the reflection, this is the direction that you're going to place the curb. So you got a 50-50 shot if you don't know how it was, where your template origin is. In my case, I'm pretty sure I need to go in this direction, and then I just give it a exterior boundary or exterior angle, and it creates that curve all the way around that element. Now, it's also created these 3D lines as well, and you could use these 3D lines to clip out this terrain using the terrain clipping tools. So I'm sorry, you want to use just like we did in chapter 1 where we actually created the little clippings. So you're going to locate the reference terrain, which will be this 98. And you want to clip out internally, and you're going to create a new terrain here. So you've got to create DTM proposed here. And this will be INT 98 underbar clip. So it's got to create a brand new one. And then locate the clipping element. That would be this one. And reset when you're done. No horizontal, no vertical. Internal. And now there should be a whole nother terrain out there. And if you look at the civil models in the terrains, there's a DTM clip and a DTM intersection 98. If we take this one here and we'll just go to the properties and we'll turn off the triangles, you'll see that since there was 2 of them displayed there, this one actually clips out. So this is the one we're actually seeing. And once you have that one, you can't, I was going to just delete this one. But what happens is this one is created from that one, and this one is created from all the elements that are based on the corridor. So you really don't want to delete this one. I just wanted to show you how easy it is to clip it out. And then the other thing that you can do very easily is you can create a terrain from elements. So like this top of curb line here, if I want to put in just a grass shape, all I've got to do is go to create from elements and then select this 3D line string. And before I do that, I'll tell it that this is a boundary element. And the feature we can actually pick from our ditch slopes, or we could use unpaved shoulder, which I know is grass. Shoulder unpaved, or shoulder this one right here. And then select this element and reset boundary, edge method none. And it should have drawn that in. Sometimes it takes a while to display it. So if I click in this view, it may be just that the feature on it. So a lot of times you just have to go back to the Project Explorer in this one here. The other thing you could do is just add a surface template to it. Let me just edit this property here. And it's just the triangles aren't turned on. I'm not sure why it's not letting me do that. Probably because it's not the type of. You go to the feature here, change this feature to a DTM existing instead of one of these shapes. And the DTM existing is green. And then if we turn those triangles on, so the terrain is out there. You just kind of got to figure out how you want to get it to display. And then now I think it actually lets me go in and change the feature type to as long as it figures out that it's a terrain model first. So that covers the turning islands, sidewalk ramps. I'm not sure how these are going to work. We'll try it anyway, but let me go to a 2D view here. And in these civil cells, we have, where'd the dialog go? I think I just turned it off. Let me go to my tool settings and pick. You'll see that we've also got the sidewalk curb ramps. And these, we were starting to build the 2D versions of them. So I can attempt to place a couple of the 2D. These ones here are definitely a work in progress. But our idea was that we would have all the various different curb ramp types in here in 2D, but then also have them in 3D as well. And so we've only really started testing on a few of these. But essentially it's doing the same kind of thing. We're going to go in and build the 3D versions of these so that all you'll have to do is select a couple of reference lines, and these are probably going to fail miserably, so bear with me, but let me try to do it over here. And in this case, it wants to know where the edge of pavement is, which I turned off in this view. Let me just F6 out of this and select this view. And sometimes it pavement asphalt. Yeah. See, I've even lost a line over there, but at any rate, I'll place maybe one of the 2D ones and you'll get the idea. I think placing these is pretty straightforward by now. Let's see which one is the B. This would be the 2D version. You would select the reference edge of pavement, and then of course you have to have a sideline. And so I would locate I don't know what happened to my edge of pavement lines, but they seem to have disappeared. And I know I turned them off, but why I can't turn them back on is another thing. Oh, I think it was a global display, a view display thing. That's what it was. All right, so now if I select this edge of pavement line, it will ask me for this line here, and it will attempt to draw in all the construction lines as you see. And I can go ahead and reset and accept it. And it places that whole 2D. And if I move this line, you can see I can move this thing all the way around there and it will regenerate itself. Well, it should. And there it goes. You see it's also skewed, so this one actually works up skewed, so you would want to basically place it in there like that. And then we're working on 3D versions of these as well. We do have one that's out there in 3D, so I could attempt to place one over here. I don't know how it would work. You need to have profiles on the back, where this one doesn't have one, and you need to have a profile on the front. And so it's been a while since I've tested this one, but let me just draw a line out here and do it like this. And just because of the way these seem to be working, what I'm going to do is just create well, I can get the profile for that line from the model. So I'll go to the model and I'll say, select on this line the profile from this view right here. And then if I hover over this, there will be an active profile. But for some reason, it doesn't always like those lines. So what I'm also going to do is come over here and do a horizontal geometry, single offset partial, I'm just going to call this there's a ramp in here, sidewalk ramp. I'll just call this sidewalk back also. And I'm going to set it offset here 2 feet. Locate this line, and then just kind of go from here. And has a fixed length there, so I'm going to turn that off and just go to here and mirror no, because this is about the area where I need a sidewalk ramp. And then I'm also use the vertical geometry, and I'm going to do a project profile to range to element. So then I'll select the element to project would be this one, and the element that I want to project my profile onto is this one. And then you just give it the limits of that line, which is basically beginning and end. And now this line also has a profile, and it's the same profile as this. Now if I want to move this closer, let's say I want to move it to, instead of -2, I can set it to 0. And now it's really just a new element because the civil cell seems to have trouble with it, and it has a profile, so I could try to use this 3D. And I'm going to pick the 3DB in the curb ramps. And pick this, which has a profile. And then the green line. And then I'll need to change the orientation of this. And if I want to change the orientation of this, let's see what happens. Yeah, it looked better the other way. And you can see some of the lines, actually it's not that way. It looks better this way because of the curb. And then if I reset, accept it, it's going to attempt to draw the 2D and then also model in the 3D. And once you have it, then again, it's just a matter of adding a clipping reference to clip that out. So if I go to the corridor modeling, I'll add a clipping reference to this corridor now, which is my linear template around this radius. And then I just have to find the boundary of my ramp, 3D ramp, and reset. And now I've got also to clip out this part with this part, this little curb line. Reset. And I should have a curb ramp in there. I guess that last clipping didn't work too good. Let me turn to F7. Some of these. So let me try that one more time, and then I want to cut a section through this. So I'm going to add a corridor clipping on this outside corridor here and use this as the clipping and reset. Okay, so you can see it's looks like there's a little bit of an issue there with the back of that curve still showing up, but now once I have that, I could come out here to this and go to a cross-section view. If I get that up and open up view 4. And right now I'm right here where there's a shoulder. So I'm right here where the shoulder and the sidewalk are basically the same. So there's a little transition that needs to happen there. But then if I move forward here, eventually I'll get up into this ramp, and now you can see the ramp there. I'm in the middle of this ramp. If I move forward, it's actually sloping down. And it looks like there's just some extra points. This is an extra line in here. The old type F is still out there. And I could fix that very easily by turning off that type F ramp if I wanted to. But it gets it's a pretty quick and dirty way of doing these ramps throughout there. So that covers the ramp. Let me see. There's just a few minutes left. The retention pond design, we actually did a retention pond design in, we recorded the webinar for basically doing the same thing. You kind of place a template that basically represents the shape of your pond along a perimeter of your pond, and then it will actually put the berm and find the bottom elevation for you. You can control the top and bottom of your pond elevation stage and do the analysis. That is actually recorded and posted out in our webinar sites. It's in the same design and 3D modeling folder, if you will, out in the posted websites. Restricted left turn islands, we haven't really built one yet, but I think it would just be a matter of building the 2D civil cell that works off of dimensions, and then you could run, just like I did with this traffic separator nose, you could just run a half template around most of it and fill it in, or you could run a curb template around it and fill it in with concrete, just like I did with making this a grass slope. We just haven't built that one yet. We're getting around to it. Roundabouts have, Bentley delivered some in their DGN libs that we started to basically try to build in our workspace by changing some of the features, and that's another thing that we have on our list to do. I can show you that you don't really even need to have civil cells to build these. Show you a particular project that was done by hand using all SS3, basically using the same site modeling tools that we've been working with here. So if you look at this DSGN file, if I can find it in this list, right here. This is a project that was that our office helped just guide along using the SS3 site, well, not site modeling tools, but corridor and detail modeling tools. And I'll just open this view up here, turn off this. So you can see this is actually 3 roundabouts, a couple intersections here. And if I zoom into it, I'll turn off these constructions. It's all done. It's all done with the FDOTSS3 workspace. But here you see curb transitions that were built in. We did this with the actual transition tools within the corridors. We actually ran a corridor around these boundaries, and then we had it transition using the actual corridor transitions, where you actually have one template shape here and one template shape here, and you let the transition lines do the actual transitioning. You can see how it slopes out for the drop curb there. There's also breaks here for the sidewalk ramp around there. This is a pretty simple, basically linear template that starts, actually it can go along a profile on this inside edge of pavement, and then basically have a slope line out, and then basically build everything back into the middle there. And then you have all these sidewalk back here, and then this is just a matter of building terrains in between the boundaries based on the 3D profiles of all the rest of them. So it's it's definitely achievable. You can get really good. This is a sample of the driveway, the 3D driveway, parking lots back here with a parking lot curb. So it's basically 50% detail modeling and 50% what I say corridor modeling. You let the corridor do certain parts of it, and then you go in and you just detail model out the rest. And you can get very sophisticated looking models that anywhere you cut a cross section, you're going to get a true representation of what the cross section would be, not not a distorted cross section, if you will. So let me take a look at the questions, if there are any questions out there. But that covers pretty much what I had. Okay. Doesn't look like there are any questions at this point. Obviously, the 3D civil cells are kind of a work in progress, if you will. With this first release, we focused on the civil cells that would complete this data set and give you some good examples. We certainly have more work to do along those lines of creating certain civil cells that would be useful. If you all come across any that you think we ought to try to start working on here, please forward us that information. We have a pretty good list already, but we're certainly taking anything else. And I think this is the last of this design and 3D modeling series, so you won't hear from me for a while. If you do want to access the recordings, feel free to go over and download those. We try to keep them to within an hour, and looks like we've completed today's hour. So thank you all for attending, and I'll see you at the Design Expo.